Hello, and welcome to the webinar on AI and testing, not just a buzzword. I'm Christina Cardoza, news editor of SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand in about 24 hours after the event. Secondly, we will be doing a live Q&A after the presentation, so you can submit your questions through the control panel's questions tab at any time during the event, and we'll try to get to as many as possible. Here at SD Times, we hear a lot of buzzwords in the industry come and go, but artificial intelligence is not one of them. A recent World Quality Report found 86% of respondents are looking for artificial intelligence capabilities when selecting new QA solutions. Joining us today is Coviton CTO Frank Moyer and Product Manager Alex Drag to talk about how AI fits in a modern testing world and what we can expect from AI in 2021 and beyond. So to kick things off, I'm going to throw it over to you, Alex.
Thanks so much, Christina, and thank you all for taking the time out of your days to join us on this webinar around AI. Not just is it a buzzword, but also how should we approach AI in the world of testing. And let's see if I can start here. So if we look at the agenda, what we do want to cover today, first I want to quickly have a moment for us to introduce ourselves as speakers, but also introduce who we are at Coviton. I won't take too much time doing this so we can get to the meat of the conversation, but I think it's helpful to sort of set the context for this conversation. And then I'm going to start with an honest conversation about AI, and then you all see what I mean by that once we get to that point. Then I want to pass over to Frank to talk about where AI fits in the testing world today, and how you can actually start leveraging AI within your testing strategy starting now and going forward into the future. And then, as Christina mentioned, we will have live Q&A at the end, so please do submit those questions in the Q&A and chat panel on your end. So with that, to quickly introduce myself, my name is Alex Drag. I'm head of product marketing here at Coviton. There's my LinkedIn if you do want to connect and reach out. So I am overall product messaging and making sure that our platform story is not only understandable and consumable, but helpful to the wider market at large. Frank, I'll hand it over to you to introduce yourself real quick.
Yeah, so I'm Frank Moyer. I'm the CTO. I'm also responsible for our product strategy and our product direction. I have a degree in computer science. I love technology, so I love the topic that we're talking about today, and I look forward to going through it. Thanks, Alex.
Awesome. Thanks, Frank. And with that, let's take a few minutes to see and to talk about who we are here at Coviton. Right? So we really see ourselves as the platform for quality-obsessed companies. And this looks like offering solutions that are going to allow you to build better mobile and IoT products, test those products and solutions much smarter, and ultimately, as you grow, we want to be able to provide solutions that can grow alongside you. So the ability for us to scale together. What this looks like ultimately is the ability to eliminate app abandonment, accelerate your automation, and ultimately convert more opportunities on your mobile channels with the industry's only mobile experience platform. We have some of the industry's leaders within their specific verticals using the Coviton mobile experience platform to drive serious value today, such as Wikimedia, using them they're in their testing, ensuring that their products perform well in the real world. eToro securing and providing this next generation cryptocurrency and trading platform, and Rakuten, who is using Coviton to tame and scale for test automation across large amounts of real devices, all available in the Coviton Real Device Cloud. But the real question is, how would you use Coviton, right? You've seen how they might be. And the exciting thing about us is, when most people think about mobile testing or mobile quality, most people are thinking about real device infrastructure. How do I make the most real devices accessible in a manner so that I can test my application or system on those real devices? But with Coviton, we see ourselves, and we offer that, right? We have the industry's most flexible, most high-performing device cloud out there, whether that be through public, private, local cloud, on-premises solutions, or building a hybrid solution that allows you to combine the best of all these different worlds for this unparalleled, flexible, real device infrastructure. But beyond that, we see ourselves as so much more than just a real device provider. We wanted to make sure that we provide solutions that actually make your day-to-day quality-related activities a whole lot easier, faster, and simply just more enjoyable, right? And we see this as stretching across the SDLC. So the reality is that quality, I think, as we all probably know, doesn't start with the tester. It actually starts with the developer, right? So we provide solutions that allow you to prevent issues from making it into test by having the ability to debug on real devices directly within your IDE. And then once that code is pushed to test, we offer a bevy of solutions around comprehensive quality within our intelligent quality suite. They look like solutions around manual and automated functional performance and visual testing. One of the exciting things here is when we talk about this automation, we'll talk about this a little bit more later today. We offer solutions that look like AI-driven scriptless capabilities for teams that want to get to automation extra quick. but also AI-assisted scripted capabilities that make your existing script-based solutions even better and more productive. But we also know that finding issues with tests really isn't all that helpful unless you have abilities to resolve and fix those issues, right? So we've built the industry's best test and exploration and remediation capabilities for issues that you find running your automated manual tests on Coviton real devices, as well as, of course, the ability, once you find these issues, to debug them, right? And debug applications on real devices straight within your IDE. And then here we see ourselves as making continuous testing for mobile reality, making mobile DevOps actually possible with what I like to refer to as purposeful integrations with your CI/CD tooling. What I mean by this is, your Jenkins integration with your test automation is only as useful as your test automation is reliable, right? And that reliability of your test automation with Coviton is something that we take very seriously. So we see our solutions allowing you to kick off test automation with the ultimate confidence, making continuous testing truly a possibility for mobile teams. And with that, now that we have, we sort of opened this up with a conversation around who we are, what Coviton is doing in the industry, I do want to start this conversation. We're going to talk a lot about where AI is in testing, why it's useful, what you can do. But I want to start with a sober conversation. Let's have an honest conversation about AI. There's a question that I think all of us are asking ourselves often: is AI just a bunch of BS, right? Because the reality is, it's everywhere. If you type in sort of the AI lingo, AI-based, AI-powered, AI-driven into Google, you're going to see a whole lot of different options, right? I see dog collars, chatbots, copywriting, bikes. I've seen AI-assisted toothbrushes out there. I'm pretty sure I have a massage gun at home that is also AI-driven somehow. And this, what does this do, right? When you see this absolutely everywhere, it does force the question: is this legitimate at all, right? And I think that the market is catching on. People are getting distrustful. If you type in "is AI bull," you will see all of these results pop up in Google, right? I mean, there are actually, if you see here, there are Twitter accounts and blogs related specifically to pointing out AI from sort of the bull or fake AIs, right? So people are getting distrustful. And if you see some of the content, I actually clicked into some of these links. You're looking at TechCrunch, right? AI powered is tech's meaningless equivalent of all natural. The travesty of artificial intelligence, pretty strong verbiage here. And then here you'll see Tala, AI bull, hype, and a little magic, right? How to make sense of it all when buying AI solutions. So I think that, look, this can make people pretty cynical, can make us like, look, don't give me AI, just give me something that works. I don't even want to hear your AI claims anymore. But I do think it's useful to maybe take a step back and let's look at what some of the industry research says, right? And I think it was mentioned earlier, the World Quality Report this year looks at AI as being something that's here to stay, is helpful if present, but is really very, very promising looking forward, right? So if you look at some of those quotes from that report, the uptake of artificial intelligence and machine learning, QA, has been growing gradually, while some of the use cases are maturing and others are still getting evaluated. Expectations that AI and ML can bring to the quality assurance realm remain high, while adoption is also on the increase, but some organizations, while they're blazing trails, there are few signs of significant general progress, right? So it totally falls in line with some of these distrustful feelings around the subject. And they ask a question here: is AI now a key criterion for selecting new QA solutions? 86% of respondents said yes, right? So if you look at this, and once again, this is something that is specific to testing, this World Quality Report, you look at this percentage here, to what degree the following statements reflect your plans to utilize AI and AI activities. In the QA activities, 88% say that AI is the strongest growth part of their test activities, right? 80% saying that they will have more AI trials, such proof of concepts in place. The lowest being 71% here, saying that we will use more AI in our test execution activities. So clearly, a majority of QA teams are interested in AI, regardless of some of the claims around AI maybe being meaningless or the tech equivalent of all natural. Although that is understandable, given once again the fact that everybody does claim it. When it comes to what is Coviton's take, I think the Tala is right on, right? It's bull sometimes, it's hype other times, but it's also a little magic, right? And that's what I want to tee this conversation off with this point, because I think that Frank has a lot of great content prepared for us today to sort of talk about this a little magic portion of AI. So with that, Frank, I will pass it on to you to open up a discussion on what this means for the tester.
Great.
Let me
Thank
give you.
Yeah.
Absolutely. And you should have. Let's see. Actually, I'll continue clicking. So I will start you off.
All right. Thank you very much. And my goal here is to educate you as a buyer of AI products for QA. So a lot of this is around terms, expectations, and in the current day, and then what to expect in the future. So first, let's get a level set on the terms related to AI. AI is short for artificial intelligence. And when you think about AI, it's this really broad term that, if you look at the definition, is very broad. It's essentially any computer program that does something smart. So you could argue that everything is AI, but let's hone down that definition a little bit and really talk about some statistics or heuristics that might be used in making decisions. So a good example of AI that is not necessarily machine learning is to choose which tests to prioritize based on prior test failures. A simple heuristic that says, these tests tend to fail, so just prioritize the ones that fail the most. And you can advance that to some degree without adding any sort of machine learning or deep learning. But a subset of artificial intelligence is a field of machine learning. And this is where programs can learn from experience without being programmed. Now, we take that a little bit further, and not all of machine learning is deep learning. So we'll talk about deep learning in a second, but for machine learning, it's going beyond just looking at the prior test failures, but also clustering. Clustering is a common machine learning capability that can look at code complexity and decide not which tests to prioritize, not just on prior test results, but also on the clustering of code complexity. Again, we haven't gone into what a lot of people refer to as, it's called a neural network, which looks at a way for, and that's what's used in deep learning, to learn from prior decisions and make better future decisions. So, this is what the human brain does when a child learns to walk. They fail, they learn, and then they get better and better, hopefully. And then if you look at this, we're looking at a feedback mechanism, and this is really important to where we go to, and then on the upcoming slides, sort of expectation setting about what's out there today, and how you can use true deep learning to make, when you're in the buying process, to understand what capabilities do they have. Or is somebody talking about AI? Are they talking about machine learning? Or are they talking about deep learning when what they have in their product? So the example of deep learning is choosing, which tests to prioritize, not just based on prior decisions, but where were defects missed? If now you start to see defects that occur in production and you can feed that back in, the neural network gets smarter and smarter over time. And Alex referred to this a little bit, but we have a few different, the way I look at it is it's used in a variety of different types of testing today. On the navigation side, and I'll talk a little bit briefly about bots later, but also just helping with the authoring process, making the authoring faster. The next is in taking all of the output, what I call the exhaust from the test, and running assertions against that exhaust. How can artificial intelligence as an overall umbrella help with assessing the performance, visual verification, and functional testing of your application? And I'm going to sort of fluctuate between mobile and web, talk about both, but these concepts apply to both. Make sure I have this right. So are you pressing, Alex, or am I?
Sorry, I'm pressing.
Okay.
Cool. I couldn't give you control of this one. Yeah.
So the first thing I wanted to do is just talk about expectations. And I think a lot of disappointment, back to the hype and BS that Alex referenced earlier, is it's part of it is expectations. We come from a world of traditional systems that are deterministic. If the account balance is greater than a certain greater than 0, then you can deposit the check, otherwise notify the customer. Simple if-then type statements or if-then else type statements. It's deterministic. When you start working in the AI world, it's probabilistic. So you don't have the determinism that you do in traditional systems. So you ask a question, which is, should the check be deposited? And it's based on a lot of features that go into that decision. And the yes and the no are not clear cut. There are going to be cases where you say yes and it should have been a no, and cases where you say no and it should have been a yes. And we're going to, the next thing we're going to talk about is what that means in terms of choosing technology for AI and how it applies to testing. And I'm going to go into a little bit of, some what's called a confusion matrix here, because I think it's really important when you look at your assessment of technology, AI-based technology, and how you should be evaluating it in the buying process. When you look at this probabilistic approach, what ends up happening is you have on the horizontal axis what actually the result was in a test. And then on the vertical axis are the predicted values. So in the case of the upper left quadrant, you have this concept of a true positive, where the system, the AI system, predicted that there is an issue, and indeed it was an issue. This is what we want to see. We want to see a lot of, okay, it found that there was misalignment on this field, and indeed there was misalignment. I'm going to jump over to the bottom right, which is the true negative. So these are things you never hear about because they're not issues, and that's a good thing, right? You don't want the system to raise issues when they're not issues. So we really want to maximize the upper left and the bottom right, where the AI engine is getting the answers right. In an ideal world, that's all you get. But again, we're dealing in a probabilistic world, and that's not reality. So I'm going to talk about how I see QA and when it comes to AI. When you go to the upper right quadrant, the yellow area, that is the false positive. So this is where the system says, or the AI bot says, the AI system says there is an issue here, but it's not truly an issue. And the first time this happens, you're like, okay, it's getting it wrong. If you get notified about that same issue over and over again, that can be very annoying, and you start to lose trust in the system because it's telling you the same thing and you've given instructions not to tell you about that anymore. The part that is really important to optimize for and to eliminate is the bottom left, which is the false negative. These are the things that sneak through, the test issues that sneak through that are not caught by the AI capabilities, and they should have been caught. And these are false negatives. So in testing terms, that's it's an issue, like there's a crash that's occurring, and the crash was missed. It wasn't considered a crash, or there was a performance issue that was not reported. And those, those, as we'll go into in the next few slides, are really what we need to eliminate completely. And we'll talk about that as we go on. So when we talk about how AI is measured, and this is what, when you're going through an educated buyer will be looking at, is how do you measure, your success when somebody says to you, yeah, we have great AI for visual verification. You should be asking questions about precision and recall, right? Like what is the what percentage of the time, precision is the percentage of time the algorithm reported true positives versus, overall true positives plus false positives. And recall is, what percentage of the time did the algorithm report true positives and compared to false negatives. And if you think about this in search terms, Google this is how Google measures their search, right? How often did it indeed find what I'm looking for, and then how many times did it return something that I didn't want it to return. So going into a little bit more detail in terms of what does this mean to testing for precision. This is the sum of, this is true positive divided by the sum of true positive and false positive. How often did the algorithm get the true positives correct? And this is, this is the annoyance factor. So some of the questions: how often is a visual difference reported, but it's not a problem? Performance issue raised, but it's not an issue. Functional issue raised, but it's not an issue. All these are examples of precision that, again, it's not, the important part when you're assessing a product here is to make sure that that you don't get annoyed, right? You have the feedback mechanism where the user can say, this is not a problem. The tester can say, this is not a problem. And you don't get notified about that again. That's where it becomes sort of not just annoying, but also time consuming. And then this is the one that is when you're evaluating AI solutions, making sure that this is as close to eliminated as possible. And I say as close to eliminated as possible because it's in the world of probabilistic algorithms, it's impossible to completely eliminate it. But you're looking at how often did it miss things? How often did something sneak through? And it's a lot more difficult to assess this because you're assuming that you catch it in production. There might be an issue like a misalignment of text that the AI algorithm should have caught that nobody ever reported in production, and it goes on potentially for a year. Obviously, bigger issues like a button isn't clickable becomes a lot easier to evaluate. So these are things like how often was a visual difference missed, but it was not found by the algorithm. So that goes with functional, performance, visual, you name it. And the important point is you can't have both. These precision and recall, it's a balancing act. You're balancing between how much the developers of that algorithm will determine whether they want to weight heavily towards false positives or false negatives. Do they want to maximize for recall, or do they want to maximize for precision? So going on to how does that work in terms of, as you increase one, it decreases. As you increase one, it decreases the other. That goes into, on the left-hand side where you're maximizing for false positives and you're minimizing for false negatives. This is where we want to be. And what this shows is actually the developers of the algorithms also have the ability to put thresholds there for you. So you can say, listen, I don't mind being annoyed a little bit too often. I just want to make sure that I don't miss anything. And so, another assessment criteria is, can you adjust those parameters in a way that gives you as a user more control over how often you get notified of issues, and then how often, or what's the likelihood of something sneaking through. So I'm going to talk a little bit about products that are out there today that are using AI across different facets of testing, different types of testing. And this is more of a practical guide. It's not meant to give specifics on how any one product is better than others, but you can see based on the maturity, which ones are sort of leading and which ones are lagging. You can go on to the next slide. So, probably the one that has the most popularity in the market right now is visual testing. There are a lot of companies out there that are either doing it today or emerging or building product around visual testing. And the example here is a simple one, right? AI and image processing is used to compare one version of your screen to another version. And the difference may be as simple as a pixel level difference, which can be very noisy, to more sophisticated algorithms that understand what the intent was in the change, and then only alert the tester to where there were issues that they found that were, that looked like issues. And so, the recall here, sort of what the goal is to identify and highlight differences with a new release or build between versions. Now, there are things that products can do to improve the precision, right? To reduce the number of times that you receive false positives. And one is to provide an interface for you to annotate the differences. And then the next is obviously to remember those. It's important to not just to annotate, but also to remember from release to release. The tester said this was not an issue. This was, for example, dynamic content. And I should not, as an algorithm, I should not evaluate this piece of content from release to release going forward. That will still maximize recall and start to increase the precision because you're not getting notified about a bunch of false positives. When I look at individual organizations that are doing this today, I want to talk about how some of these products are out there today and what they do. The first is Applitools, and Applitools has been the pioneer in visual testing. They started back about 7 years ago, and they've done a lot with regards to visual testing. They've really been advanced in this space, and they come at it from a understanding context, right? They understand that there are different comparison levels, that it's not just you can't just compare pixel for pixel. They pretty early on figured out, well, you have to handle, there's something in image processing called anti-aliasing, right? When you take an image and you change its, even its resolution slightly, you end up having a pixel by pixel difference. And if you look at a pixel by pixel difference, you end up, everything will be changed, even if you just change the resolution slightly. So they have this other level called strict, which says, we're going to take out the anti-aliasing. So we're looking at, still it's going to be pretty much close to pixel by pixel, but we're going to account for the anti-aliasing. And then the other two that they have added, which are really neat, is one is content. So when you're evaluating, when the algorithm's evaluating something, when you're doing the comparison, only evaluate the content. Don't worry about the layout. And layout is, just look at the layout, don't worry about the content. They have an annotation interface that allows the tester to annotate and reduce the false positives, increasing the precision. And they have for mobile, they have an API that you call for every step in your test, and you post the image, or you can actually put some instrumentation in your mobile app code to capture that. A company that was just, the next one, company that was just recently acquired by BrowserStack called Percy, similar comparison levels to Applitools, but they just do exact and strict. And they can compare full screens or components just like Applitools does. Definitely meant more towards the developer side than the tester, but they were acquired by BrowserStack probably about 6 months ago. And then Sauce Labs is they have some programmatic interface for visual comparisons. It's hard to, they didn't have a lot on, I've seen the prior two products. I haven't seen Sauce Labs product, but they have some programmatic interface to quote unquote eliminate false positives. Again, a way to, in their website, they actually acknowledge certain AI-based terms. And then Nova by Koviton, similar to Apple tools in terms of comparison levels, exact strict content layout. Also an annotation interface to reduce false positives. The one thing that Nova does is that it also infers dynamic content. So there's no need to, in many cases, no need to annotate. It does it automatically. It can do that just by looking at iterations and iterations of tests. And currently it's only on mobile for native hybrid and browser. But so those are sort of what's out there today. I'm sure I've missed a few, but these are the key ones in the market that I've seen. The next one is one that's only offered by Nova, by Coviton, and this is really cool. It's allows testers. Testers historically have been asked, and this is through multiple interviews where customers are asking for the ability to assess the UI design, and the testers are being asked, how can we know whether the design was implemented correctly, and how do we know that this is a good design? What typically happens with developers when they get the design is they will put some algorithms around, unless you're an Uber or an Amazon and you have the ability to pay for designs for every different screen resolution. You are typically getting one screen resolution, and it's left up to the developer to make some choices on how they implement it. And you'll see this example here, where on a Galaxy Note 8, this REI application looks pretty good. When it is rerun on a Galaxy J5, the font size, because of the screen resolution, just is increased automatically. That ends up with a lot of problems. Not just visually is it painful, but also it's actually you've got the login button and the create account are occluded by the no thanks. You've got stuff that falls off the bottom of the screen. This is the Nova capability actually trains a machine learning algorithm on the top 50 mobile apps in the marketplace, and you can then apply your app to those top 50 apps to identify where there are items that are anomalies when it comes to UI design. So really, pressing the innovation on deep learning with this algorithm. There's definitely sort of next down is on the performance testing side, and anyone who's been involved with performance testing probably, and when I say performance testing, it's a broad term, so I want to be specific about what I'm referring to. I'm referring to the testing the response time between when a user interacts with the application under test and when the application under test gets to its next state. That response time testing is often very challenging, but probably the most difficult part, if you've ever been a part of a performance team, is not executing the test, but figuring out what the hell went wrong when things were not to expectations, right? So doing the root cause analysis, is it time-consuming task? Was it the network? Was it the back end? Was it the app? There are all these different things that it could be. And so, this is different ways you can improve the process is by helping to explain the root cause of any issues during your analysis process, and then also compare your executions to prior executions and allow for multiple executions. So it's not just 1 against 1, you're comparing 10 against 10. So some of the companies that are doing work in this space, the first is Headspin. They have a detailed report of client-side application performance. If you are really wanting to drill into, in the stack of calls within the code, what was actually called and how long did each step take, they have amazing analytics on being able to do that. They also have a correlation report that looks at anomalies for response time. So again, helping to prioritize, they can say, it looks like this image is being loaded and it's a large image, it's holding up the rest of the rendering. And they also do system metrics, so you can look at CPU memory together with that test. Neotis, the Akamas is an AI-based solution for performance improvement. So they're looking to optimize how you improve performance, different ways you can do it. And Neotis has been a leader in performance testing historically. It's one of Coviton's partners, and they know this space really well. And then on the Nova by Coviton side, there's the ability similar to what Headspin does, but it's actually explains using a statistical term called marginalization. It marginalizes the different features that are related to a regression in performance and being able to explain what the likely root cause is. Also, system metrics reporting, much like Headspin. So I'm going to just briefly talk about some of the other areas for that AI is used today, and some of the different ways I see it used in the future. Before I finish off and talk about what the limitations are. OCR has been used in testing for years. It is an AI algorithm. OCR is, in some of the later versions of OCR, like what's used in Google Vision, is actually takes that to a deep learning realm. The next is, something that I have to admit I don't support. I don't agree that it's the right way to approach, but there are companies out there that just write crawling bots to identify, potentially identify testing issues. And this does a depth first search to go through the app and all the branches of the application. It's similar to what Google does when they're crawling a website. They just go through every possible link and find all the possible links, find broken links. And this helps identify, untested sections of an application. I see it valuable in terms of identifying potential risk areas because it hasn't been tested in the other parts. But just doing it as hey, this bot can go and run your test is, and as I'll talk about on the next slide, is not much value from my perspective. Predictive analytics is used quite a lot right now to prioritize high risk areas for a release. So you can start to merge code changes, right? Matching up code changes with the app, with the binary, looking at historical defects, and then also production usage, right? Should I be testing on different device types? Should I be testing on iPhone X? And should I run the order entry test on the iPhone X because that's what's been changed this release, and that's who's using. That's the device that's being used most often in the industry for my users. And I sort of get excited about some of the latest technology around deep learning, and generative adversarial networks is something that essentially, if you've ever seen the movie War Games, where you've got this back and forth between the system and itself, it sort of fights itself and it comes up with a conclusion. And I think there's some pretty cool things around generative test data that I've been working on over the past few weeks that allow you, potentially could create some really powerful ways to generate test data that makes it much more efficient than the traditional ways of getting to good test data for your app. So, right, like, gosh, it does everything, right? Well, there are bounds, right? It's not, and I point out autonomous vehicles, right? Because autonomous vehicles operate, the promise is to operate without a driver. And so will we actually get to a point where AI can do everything, where you don't need testers, where you can just send your new release and it just does it all? And even though, like, getting to autonomous driving is a really hard problem to solve, and it's being solved. The important point here is its domain is limited, right? It's just that it's really hard, but it doesn't, but it's easy to, it's easier to prepare a machine learning algorithm for a limited domain. Just autonomous driving took millions of hours of research and development to get to where we are today, and I'm sure millions more will follow. But with an application, there's a lot of knowledge, subject matter expertise that goes into testing. And it still, that we will continue to require a tremendous amount of testing knowledge and subject matter expertise. I did a webinar a few months ago about, is the tester the new product manager, right? So the tester knows so much about the application because they just have so much domain expertise, and they have that ability to really own, from a product knowledge perspective, that part. Machines are really good at checking, right? So for all the stuff that I went through before, it was checking, right? It was checking the text, it was checking the visual alignment, it was checking visual differences from release to release. But humans prevail when it comes to actually understanding the context and understanding the subject matter. So, I think we're in the early stages of using this technology. It's really powerful, and wherever you can find the right products to help you get more efficient, great. But you're still going to need testers.
Awesome, thanks, Frank. So that's a lot of information. As you mentioned earlier, you made a comment. It looks like AI can do everything. When it comes to functional, visual, performance, and a whole lot within those specific categories. So as we wrap up and sort of head into questions, I do want to just kind of tie a bow on this, right? A nice neat bow, and look at what is the actual goal of all of this, right? The functional, visual, the performance, all this stuff. And the real major overarching goal of all this, let's make testing continuous, right? And speaking from a Coviton perspective and bringing the mobile and IoT space, this is really hard. There's been a lot of progress in this area when it comes to desktop web. I've even spoken with testers that say our web team is totally integrated into CI/CD, but mobile, we can't do it. So it's really, really difficult, right? And what does this look like, this making testing continuous? It starts with the authoring, right? How do we actually make the authoring of test plans, test cases, on the test management side, but also the authoring of test scripts? How do we make this more efficient, more stable, faster, and maybe at some point, I guess good enough, autonomous to some degree, right? Then you're looking at execution. So you can write your test script, you can create your test case and plan. But the minute that you hit run, the minute that you tell it to go, is it going to be an adapt, right, to different changing environmental conditions? Is it going to be stable enough to be CI/CD friendly? I mentioned earlier the purposeful integrations with CI/CD tooling. You're going to be able to kick off those tests with confidence. To speak a little bit to the mobile specific thing here, this is where device fragmentation becomes such a pain. Can it actually execute across all these different device types, operating systems, screen sizes, screen resolutions, without giving you false positives, false negatives, and also just breaking and stopping execution as a whole? And looking at assertions, right? How do we actually add this sort of comprehensive nature to our test scripts so that their application can be a bit less limited than a traditional functional test script, right? Can you add in visual, performance, security, accessibility assertions? So essentially at the end, you can have sort of one test to rule them all, right? Catch all these issues. And once again, this sort of ties into the authoring piece here too, right? Because adding all these assertions into your test script manually is an absolute pain. It takes forever, right? If you just want to do the visual testing piece, you're going to have that in a lot of assertions on your own to catch everything that a visual testing specific solution as of now that uses AI is actually able to do. And then the maintenance, right? Look, you can do all of this stuff. What happens when the UI changes? What happens when the source code changes? Is it going to break all of your tests, right? So how can AI be used to make it possible that when new releases have happened, you can look at the changes and update your scripts either automatically, autonomously, or pulling a human into the loop here and giving them a remediation interface so they can easily see the issues, see the changes, and quickly make the changes themselves if necessary. Then eventually at the end of it, like reporting. How do we keep visibility and traceability into our testing processes? Or maybe it might look like session exploration, right? Having this rich menu of archivable test artifacts and information, so you can go back and see, well, what actually caused this issue over time, right? And when you sort of take this combination together, if I give you an example from the Cobiton perspective, right, our 2021 goal this year is to get customers to what we call within an hour continuous testing using this Nova AI engine, right? So you see all this authoring, executions, assertions, maintenance, reporting, remediation. What we plan on, what we're really excited to deliver is a solution that allows you, from the specific time that your new app or system is deployed, your test plans, test cases, your automation, including the assertions that we bake in, they can all be updated within an hour, right? And they can be executed across real mobile devices with the in-depth reporting available once again, both during and after test sessions, all this within an hour, right? This is something in the world of mobile has just not been possible. As I mentioned, continuous testing for mobile has been such a pain. And it's our goal here to make all this happen once again, within an hour from the minute that your application changes, something new is deployed. So then when to look at, sort of a real world example of where we are now, right? That we can talk a lot about where we're going this year, but it's important to have a solution now. And one real world example that we have, Nova AI engine leading to some serious success. There's a world leading auto manufacturer who ended up having to build a whole new app, whole new system. And they were able to do in 2 weeks, creating an automation library that what took them a year and a half to do with traditional Appium scripts, right? So that's around a 39-40x improvement in speed, and they found more bugs, right? Because we have this functional and visual approach baked into this one test. Once again, it's one test that's the functional and the visual checking there. Now we're adding the performance assertions here too, so I can't even imagine what all they would have caught at that point. I mean, you look here, right? It's the difference between weeks writing all your scripts, weeks to update them when things change, hours to fix them. You're looking at maybe an hour, right? If we get to our 2021 goals, it's minutes here to actually build the automation and minutes to update, fix, and re-execute and remediate for those. So really, really exciting where we are currently here, and AI is clearly it's something that is promising now. Once again, as we go forward into the year, AI will continue to become more and more promising, more and more helpful, both in the realm of Cobiton, but also the other solutions that Frank has mentioned, right? That we're not the only AI solution out there, and I think it's important to remember that there are these other tools. Once again, it's up to you all to look at the maturity and make those decisions on your own. But I did want to point out a real example of where it's kind of killing it at the current moment. So I know we're getting close to the end here, but just a quick wrap up of some of the stuff that we discussed and how to approach looking for AI-driven solutions. We talked a little bit at the beginning about is it hype or is it BS? Right? I think we've made a great case here, or I should say Frank has made an awesome case that AI is really exciting. It's really promising. But there are a few things to keep in mind when looking at solutions, right, that claim AI. So yes, BS, yes, hype, but it's also magic. So it's important to keep this in mind, right? And the overall goal of all of these different AI solutions, whether it might be niche or expansive, is to make your testing truly continuous. That is the goal, and that should be the thing. When you hear things like people, process, technology, make sure the technology you're looking at fits the people in the process piece there, right? And that process piece especially is the continuous nature of that. So when you're looking, be cautious and aware, but not cynical, right? I think the major thing to look at with AI solutions, if you see someone making an AI-based or an AI-driven claim, whatever it might be, look for transparency. If a vendor is claiming that their AI is perfect, or they don't spend any time explaining to you any of the shortcomings of AI or where AI is limited, whether that be present or historical, I think it's the time to be cautious. So I think it's really, really helpful to look for vendors who clearly explain what their AI is, oftentimes how it was even built. There are vendors out there to do that, and why it works, etc. So did want to leave us with these last 4 points here. But now I do want to open the floor up for questions. I think we have about 10 minutes left. So Christina, I'll hand it over to you to mediate questions.
Great. Yeah, thanks, Alex and Frank. That was a great presentation. So we do have a couple minutes to get through some of the questions. If anyone has any, you can submit them now, and we'll try to get to as many as possible. So is Cobiton's visual testing the same as pixel-to-pixel and snapshot testing?
So I will start answering that question, and I'll hand it off to Frank to give us more detail. No, it is not the same as sort of the historical pixel-to-pixel and simply snapshot testing. I know that's where sort of the visual testing sort of began, but there were a lot of issues with false negatives and false positives given those given those approaches. And Frank, I'll let you explain sort of the technical differences between what we do and the pixel to pixel and snapshot stuff.
Yeah, so we've actually trained a deep learning algorithm on comparing visual elements and what should be matched as the same versus what shouldn't be. And we provide that flexibility in terms of whether you want to do a pixel by pixel comparison with your assertions, or whether you want to, what we call relaxed. So it's taking in some of these, reducing the number of false positive, reducing the number of annoyance factors when you run your tests. And one other important point that I missed when I went through the visual part was, with a lot of technology out there, you actually have to have baselines for every screen resolution when you're doing visual assertions. Well, that's a lot, right? There are about at least 25 screen resolutions for mobile. And if you have to maintain each and every one of those, that gets quite cumbersome. So, being able to infer when something is changed on one device and it's acceptable, then making sure that the AI engine can show that it was changed on the other device types without actually having to go through and remediate each and every one of those. It's a huge time savings.
Great. We have another question here about the visual testing solution. What frameworks or languages do you have to use the solution?
So one of the things, it's really cool, and I think Frank, you may have mentioned earlier, but the visual testing that we're talking about today is actually, it's completely scriptless, right? So you're not bound to a framework or language at all. You don't have to code at all to make that happen when using Cobaton. It's you essentially, you go in there, you launch a real device, test your application, you perform this one exploratory test, and then you're able to use our AI to automate that exploratory test and run that across this bevy of real devices. And then you get the visual testing and the remediations there as a byproduct. So no need to even worry about frameworks and languages there. It's completely agnostic and user friendly in that approach.
Great. Now you guys covered a lot of different aspects of testing. What other types of testing, can be assisted by artificial intelligence? And somebody specifically is asking, is anyone using AI to monitor physical defects on product inspection data or anything like that?
For product inspection data, on monitoring physical defects, I'm not sure about this. Frank, do you know of any solutions out there doing this?
Yeah, so I've seen some things implemented using AWS's machine learning. So they do they have some algorithms that you can train on what the physical, like, let's say you're want to see if there's a physical defect with a mobile device. You can run enough training samples through it using AWS, and then run the inference engine against that.
Great. It looks like that's going to be all the time we have for questions today. But before we go, Alex, I know you went over some final thoughts and key takeaways. I just want to throw it over to you, Frank. Do you have anything you want to leave our attendees with today?
No, just thank you, and good luck when as you evaluate this technology, and feel free to reach out anytime. Thank you very much, Christina, for facilitating this discussion, and thank you, Alex.
Yes, thanks, Christina. Thanks, Frank, and thank the audience thank you for joining. Really appreciate it, and we're pumped to have been able to share this time with you.
Definitely. Thank you guys for a great presentation. Again, that was Cobaton CTO Frank Moyer and Product Manager Alex Drag. And thank you for Cobaton for sponsoring today's events, and our listeners for joining us today. Until next time, I'm Christina Cardoza with SD Times.